Hello students, so here we are with the lecture 1 of alcohol, phenol and ether. So what are alcohols? Alcohol contain one or more hydroxyl group directly attached to the carbon of the aliphatic system. So if we take aliphatic hydrocarbons, okay, and in that let's take ethane. So ethane is what? C2H6. So if one H is replaced by OH, it becomes C2H5OH. So this C2H5OH is what? Alcohol. Clear? So similarly, phenols. In phenol, what happens? The OH is directly attached to the aromatic system, that is aromatic ring. So for example, if you have benzene ring. So benzene ring, if you replace one H by OH, it becomes C6H5OH. And this C6H5OH, where OH is directly attached to the aromatic ring, are called phenols. Clear? Now ethers. Substitution of hydrogen atom in a hydrocarbon by an alkoxy group. That means when H is replaced by OR or alkoxy group or aryl oxy group. That means it yields another class of compounds that are called ethers. Okay. So let's say for example you have C2H6. Okay. So in C2H6 if you replace H by OCH3 then it becomes C2H5OCH3. Or if you have methane. Methane H if you replace by OCH3 group, alkoxy group, then it becomes dimethyl ether. Clear? So ether has compounds by substituting the hydrogen atom of hydroxyl group of an alcohol or phenol by alkyl group. Or we can define it in the terms of alcohol and phenols also, that they are prepared by replacing H of alcohol or H of phenol by the alkyl group or the aryl group, then they are called also their ethers. For example, ROR dash, ROAR, AROAR. Okay. So dialkyl ether, aryl alkyl ether, diaryl ether. Okay. So these are the various types of ethers. Got it? So ROH is what? Alcohol. AROH is what? Phenol. And ROR is called ether. Clear? So classification of alcohol and phenol. Classification on the basis of number of hydroxyl groups. First is monohydric alcohol or phenol. So alcohol or phenol that contain only one OH group attached to the aliphatic system or to the aromatic system are called monohydric alcohol or phenol. For example, ethyl alcohol is a monohydric alcohol. Here you have one OH groups attached to the aliphatic system, ethyl group, and phenols are those that contain one OH group directly attached to the benzene ring. So they are phenols. Then dihydric alcohol or phenol. Alcohol or phenol that contains two OH group in their molecules are called dihydric alcohol or phenol. For example, ethylene glycol. In ethylene glycol, you see two OH groups are attached to the adjacent carbon atoms, and dihydric phenol. Right? Two OH groups are attached to the benzene ring. Then trihydric alcohol or phenol. Alcohol or phenol that contain three OH groups attached in their molecules are called trihydric alcohol or phenol. For example, glycerol. In glycerol, you see three OH groups are attached. Okay. And this is the trihydric phenol where three OH groups are attached. Okay. Polyhydric alcohols. Alcohols that contain more than three OH groups present in the molecules are called polyhydric alcohol. For example, sorbitol. Yeah. Monohydric alcohols are further classified on the basis of the hybridization state of the carbon to which OH group is attached. Okay. So, alcohols containing sp3 carbon and OH bond. So, in these alcohols, OH group is attached to the sp3 hybridized carbon atom of the alkyl group. Okay. So, let's see. These alcohols are further classified as primary alcohol, secondary alcohol and tertiary alcohol. So here you see the OH group is attached to the sp3 hybridized carbon. Okay. sp3 hybridized carbon means carbon that forms four bonds. Four single bonds are called sp3 hybridized carbon. So in this you see the carbon OH group is attached to the sp3 hybridized carbon. Okay. Now this is primary alcohol. In this OH group is attached to the primary carbon. What do you mean by primary carbon? The carbon to which one alkyl group is attached and two H is attached are called primary carbon. So hydroxyl group is attached to here to the primary carbon. That means carbon atom which is attached only to only one carbon atom directly. Okay. So one alkyl chain it is attached. It is called primary carbon. So when OH is attached to the primary carbon, you call it as primary alcohol or 1-degree alcohol. Then secondary alcohol. In secondary alcohol, the OH group is attached to the secondary carbon. That means OH is attached to the carbon which is attached to two alkyl groups and one H. So here OH group is attached to the secondary carbon. That means carbon which is attached to the two carbon atoms directly, two alkyl chains directly. So they are called secondary alcohols. Then tertiary alcohol, hydroxyl group. When hydroxyl group is attached to the tertiary carbon. Tertiary carbon, that means the carbon which is attached to the three alkyl groups are called tertiary carbon. So this is 3-degree alcohol. Example, tertiary alcohol. So allylic alcohol, these are the compounds in which the OH group is attached to the sp3 hybridized carbon, and this sp3 hybridized carbon is attached to the carbon double bond carbon. Okay, so this is called allylic alcohol. So OH group is attached to the sp3 hybridized carbon which is attached to the carbon double bond carbon. This is called primary allylic alcohol. So here you see the carbon which is attached to the OH group is the sp3 hybridized carbon, and it contains one valency is satisfied by OH and 2H it contains. It contains 2H and one CH carbon double bond carbon. So CH2, when it contains the carbon, sp3 hybridized carbon is containing what? 2H. Then it is called primary allylic alcohol. But when this sp3 hybridized carbon to which OH is attached contains one H and one alkyl group, then it is called secondary allylic alcohol. So here the carbon which is containing OH group is sp3 hybridized and it contains one H and one methyl group. And of course, it is attached to carbon double bond carbon. Then such a alcohol is called secondary allylic alcohol. While if the sp3 hybridized carbon containing OH group contains two alkyl chains, and then of course it is attached to the carbon double bond carbon, then it is called tertiary allylic alcohol. So primary allylic alcohol, the sp3 hybridized carbon contains how many H? 2H. While here in the secondary allylic alcohol, the sp3 hybridized carbon that is attached to the OH contains how many alkyl groups? One alkyl group and one hydrogen. While the tertiary allylic alcohol contains the carbon containing sp3 hybridization and which is attached to OH and is attached to two alkyl chains and one C carbon double bond carbon. So when it contains two alkyl chain, it is tertiary. When it is containing one alkyl chain and one H, it is secondary. When it contains both the H, then it is primary. Clear? So what we have to focus? We focus on the carbon which is sp3 hybridized and which is attached to OH on one side and carbon double bond on other side. Right? Benzylic alcohol. So these are the compounds in which OH is bonded to the sp3 hybridized carbon which is next to the aromatic ring. So this sp3 hybridized carbon which is next to the aromatic ring is called benzylic. Okay. So when it is alcohol, it is benzylic alcohol. Clear? So this is again classified into primary, secondary and tertiary benzylic alcohols. So in primary benzylic alcohol, what happens? The carbon which is sp3 hybridized and it is attached to OH contains two hydrogens. This is primary benzylic alcohol. And in secondary benzylic alcohol, the carbon which is sp3 hybridized and is attached to the aromatic ring and is attached to OH group on the other side contains one hydrogen and one alkyl group. Okay, so this is secondary benzylic alcohol. While tertiary benzylic alcohol, what happens? The carbon containing OH and which is attached to the aromatic ring on one side contains two alkyl groups. So when it contains two alkyl chains, then it is called tertiary benzylic alcohol. Correct? So primary benzylic alcohol, secondary benzylic alcohol and tertiary benzylic alcohol. Clear? Now compounds containing carbon sp2OH bond. So vinylic alcohol. These are the compounds in which OH group is attached directly to the carbon double bond carbon. Okay, so this is the carbon double bond carbon. This is the sp2 hybridized carbon, and OH group is directly attached to the sp2 hybridized carbon. So example is vinyl alcohol. Clear? Now, when OH group is directly attached to the sp2 hybridized carbon, then these may be known as monohydric, dihydric, etc. The dihydric alcohols are further classified into ortho, para and meta. So here you see the OH group is directly attached to the sp2 hybridized carbon of the ring. This is phenol. In catechol you see two OH groups are attached to the directly to the benzene ring, catechol. Here you see this position is called ortho position. Okay, second and sixth position is called ortho position. The third and fifth position is called meta position, and 1 and 6 is called para position. So here you see in catechol the OH is present on the first position and on the second position. That means second position is what? Ortho position. Okay. So in the resorcinol you see OH is present on the first position and the third position. Third position is known as meta position. Okay. So this is resorcinol. And then in quinol the OH group is present on the first and fourth position. So 1,4-dihydric phenol is called quinol or hydroquinol. Clear? So here you see the OH group is attached to the sp2 hybridized carbon of the ring. So classification of ethers. Now on the basis of similarity or dissimilarity of alkyl group or aryl group attached to the central oxygen atom, ethers are classified broadly into two categories: simple ether or symmetrical ether, mixed ether or unsymmetrical ether. So in simple ether what happens is that the R and R dash that are attached to the oxygen will be same. So if R is equal to R dash, that means R and R dash, the two groups that are attached on the two sides of oxygen are same. Then it is called simple ether or symmetrical ether. For example, diethyl ether, dimethyl ether are simple ether or symmetrical ether. But if the two R groups are different, then it is called mixed ether or unsymmetrical ether. So when R is not equal to R dash, then it is called mixed ether or unsymmetrical ether. For example, ethyl methyl ether, ethyl phenyl ether, etc. Okay, understood? Okay, thank you. So the summary of the classification: alcohols are classified into monohydric alcohol, dihydric alcohol, trihydric alcohol or polyhydric alcohol. So monohydric alcohol contains one OH, example is ethyl alcohol. Dihydric alcohol contains two OH, example is ethylene glycol. Trihydric alcohol contains three OH groups, example is glycerol. Then monohydric alcohol can be further classified into, based on the hybridization of the carbon to which OH is attached, sp3COH and sp2COH bond. So if it is sp3COH bond, the types are alkyl alcohol. Alkyl alcohol can be further classified into primary, secondary and tertiary alcohols. Primary alcohols, the OH is attached to primary carbon, the carbon to which one alkyl chain is attached. Then secondary alcohol is the alcohol to which OH is attached to the secondary carbon, carbon to which two alkyl chains are attached. And tertiary alcohols are the alcohols to which the carbon containing OH is attached to three alkyl chains. So it is 3-degree alcohol. Then another types of sp3COH linkages can be allylic alcohol, where the sp3 carbon is further attached to the allylic carbon or carbon double bond carbon. This is also further classified into primary, secondary and tertiary alcohol, allylic alcohols. Then benzylic alcohol. In benzylic alcohol, sp3 carbon is further bonded to an aromatic ring. And this is also three types: primary, secondary and tertiary alcohol. So this is the summary of the classification, entire classification. Okay, thank you.